Are you preparing for the
Okay, so now let's look at the solution part. So here in assertion, we are talking about experimental research. And they are saying in experimental research, the researcher manipulates the independent variable. This is absolutely true. We do manipulate. This is the characteristics of experimental research to observe the effect on the dependent variable. Absolutely correct. While keeping extraneous variable constant. This statement is 100% correct. Now I will explain you that why this is 100% correct. So let's say that you have a student and we want to check their marks on the basis of their study hours, okay, or the basis of their study hours. So say we have many students in a classroom and we have different marks for student 1, we have different marks for student 2, so we have different marks for all the students. Now we want to check that does marks of students depend on study hours. So here study hours will be your dependent variable. Sorry, study. So here the study hours will be your independent variable. So this is your independent variable and marks is your dependent variable. Okay. Now we are saying study hours as independent variable because we are manipulating study hours. So there is one student who have scored say 99% and he is studying say 12 hours every day, but one who has scored say 55%, he might be studying just 1 hour or 2 hour or maybe few hours in a week. So because of this dependency, that means there is different study hours for different students. So that's why study hours here is independent variable and it depends extraneous variable. We are keeping extraneous variable constant. Why? Because we are manipulating independent variable and we do not want any impact of this extraneous variable on our experiments. So that's why we need to keep extraneous variable constant. This statement is absolutely correct, correctly define the experimental research. Now reason. Control over extraneous variable is necessary to ensure that observed effect is caused solely by manipulation, that is internal validity. Already we have explained, we have talked about this. This is absolutely correct in context of experiment research. So what we are getting? We are getting that both A and R are correct and R is also explaining the assertion. So option B will be the correct answer. Okay, so let's see the solution part. All right, so you can see both A and R are correct and R is the correct explanation of A, of assertion. So here you can easily this is the explanation slide, you can check. Okay, so you can pause the video and you can read about this as well. All right, let's move on to topic errors in hypothesis testing. This is very, very, very important because every year these types of questions are asked uh, in different forms. They may not ask you directly, but indirectly also they will ask you question from this topic. This is really very important. So here what is given, we have been given a scenario, okay, and we have to figure out what types of error has been committed. Okay, so let's study this. Question is, a researcher formulates a null, important, not test, formulation, they're talking about the formulating, formulates a null hypothesis stating there is no significant difference between the two teaching method. After testing, the researcher rejects null hypothesis even though it was actually true. Now question is, what type of error has been detected? One error, two error, standard error, or sampling error? That we need to figure out. That one error also must apply. That two error also must be critical. You explain this. All right, so let's see the solution. So here we are talking about the null hypothesis. First, we have to understand what is null hypothesis. Okay, so the first thing that we need to understand is what is null hypothesis. So first thing that we need to understand is what is the null hypothesis. So null hypothesis is basically it tells you that there is no difference between the two methods. Null hypothesis, we define null hypothesis that there is no difference, no significant difference between the two teaching methods. So that is your null hypothesis. So null hypothesis is saying there is no difference between the two teaching methods. After testing, the researcher rejects null hypothesis even though it was true. So this is the characteristics of type 1 error. Okay, so we have two types of error, type 1 and type 2. So type 1 error is what happened, type 1 error and type 2 error. So type 1 error happens when you reject a hypothesis when actually it is true. So whenever you are rejecting a true hypothesis, so that is called type 1 error. And type 2 error is whenever you are accepting a false, it is a false, but you are accepting that that is your type 2 error. So whenever you are accepting false hypothesis, that is type 2 error. So clearly here a researcher, what they are doing, they are rejecting even though it was true. So they are rejecting a true hypothesis. So this is the characteristics of type 1 error. So answer will be type 1 error. This is very simple. Okay. Now you can see the same thing we have provided here in very detailed tabular format. This table is very important from exam point of view. You need to be very clear on this table. Okay. So the same thing, like you have null hypothesis. When null hypothesis is true and you reject that, that is your type 1 error. Okay. So this is also known as false positive or alpha. When null hypothesis is false and you reject that, that means that is the correct decision. So there is no error. No, but if you accept a null hypothesis when actually it is a false, then this is type 2 error, which is also known as beta. Okay, so now we can move to the next question. Okay, so let's deep dive onto this question. Uh, I will give you concept for each test. Now, you know, whenever you have these types of question, where you have given one side, you are given some parameters or some, uh, any concepts. So whenever you have these types of situation, when in list one you have some parameters or some concepts, and in second list you have explanation, I will suggest always go from explanation part. This will help you to figure out your correct match very easily. Okay, so what we will do first, we will study list two, and easily after reading this, easily you can guess against which parameter or against which test this will be correctly matched. All right, so let's start. So first one is used for variance analysis of greater than two groups, and already in bracket they mentioned ANOVA. So we all know that whenever you have more than two groups, then it is called ANOVA, and ANOVA is nothing but that is F test. So this will match with F test. This is concept of ANOVA. Okay, you cannot do T test or G test here because number of groups is more than two. So this will fall into category of F test. Second, a small sample size, but sample size is less than 30 and population standard deviation is unknown. So much information is provided here. Sample size is small, that is in less than 30, that is number one. Second is population standard deviation is unknown. So whenever we have a small sample size and population standard deviation is unknown, so we go for t-test. And just opposite, when large sample size, that is n greater than 30 and population standard deviation is known, this is nothing but g-test. So this is the difference between g-test and t-test. G-test, your sample size is large, that is greater than 30 and population standard deviation is known. In this case we will go for G test. But when population standard deviation is not known and sample and in this case sample size is also small, so we should go with T test. Remaining what? Chi-square, and chi-square correctly matches with 4 because chi-square is nothing but a non-parametric test, and whenever you are going for tests goodness of fit or categorical test, that will fall into chi-square test. So easily A to B1, A to B1. So answer B seems to be the correct, isn't so? Yeah. All right. So here you can see a detailed explanation. Let me in tabular format. This is you can take this as a cheat sheet. You don't need to study more than this for knowing the characteristics of different tests. Same thing what I've explained in previous slide. You can see here t-test is nothing but same thing which I explained in previous slide. You can see those have been provided in summary. This will be very helpful for your future reference. So for example, in t-test, you have a small sample size, population standard deviation is unknown, and associated with Gaussian student t-test. G-test, inverse, this is inverse or inverse of t-test. Here large sample size, population standard deviation is known, and standard normal, it follows the standard normal distribution. F-test compares variance across 3 or more groups, that is more than 2 groups. ANOVA framework by Fisher is followed here. So F-test, whenever you have more than 2 groups, ANOVA, but if you have if you have just 2 groups, if you need to compare 2 groups, then you will go for t-test or g-test. T-test if standard deviation is not known, g-test if standard deviation is known and sample size is also large. Chi-square, distinctly, this is non-parametric test. We will study this separately. What is non-parametric test? Non-parametrics are those tests where your population do not need to be normal. Okay, so whenever we are performing t-test, g-test, what you need, your population need to be normal, normal distribution. Okay, here if your population is not normal distribution, then you can go for non-parametric test, and the example is chi-square. Okay, so whenever we are saying goodness of fit, when we are saying any comparing relations between the categorical variable, we do go for chi-square test, and because here we do not need uh, normal distribution of data. Okay, example is check independence and goodness of fit. So this is important. These are your normal. These are your parametric test. T and G test are parametric test. These are your parametric test, and this is non-parametric test. This is non-parametric test. Okay. So question can also be asked in this way, parametric, non-parametric, or they can ask directly about some of the non-parametric test and some of the as well and parametric test. All right, so I hope the things are clear here, because so now we can go to the next part. No. Okay, so next question is on sampling technique. And question is, which of the following is a non-probability sampling method specifically used when the population is hidden or hard to locate? Example, finding illegal immigrants or drug users. Okay, so the question is, which of the following is non-probability sampling? So first thing that you need to look at is they are asking about non-probability sampling. specifically used when population is hidden or hard to locate. So two things, two keyword you are getting here. One is about non-probability sampling, and second, we use that when population is hidden or hard to locate. You first have to figure out non-probability sampling, and then you have to figure out in this situation which will be the most appropriate. All right, so let's look at one by one. So first is a stratified sampling, and this is random sampling. Okay, so this is not non-probability. This is probability or random. Cluster, this is also probability and random. Snowball sampling. What is snowball sampling? In snowball sampling, what happens? Suppose I want to interview a certain uh, snowball sampling. Let's understand this. In snowball sampling starts with one unknown person. Okay, so you are taking an interview of unknown person, and that unknown persons refer further to some other person. He may refer one or two person, and then that person again refers some more person, and this process is continue. This is called chain sampling also. So this is like a chain. You start with one unknown person, and he gives you some other reference for interview, and you ask those referred person, they give you another reference, and this process is continue for long, as till long as till your sample size is satisfied. Okay, so and this process is continued till your sample size is satisfied. So this is like a chain sampling. So snowball sampling is example which is relating to your question. So this is non-probability sampling. Yes, this is non-probability sampling. Why? Because you already are targeting those people whom with your reference. Not you are not selecting any random from the population, but you are taking reference from a certain person, and on the basis of that you are targeting your audience, or you're targeting your population. So this is the example of non-probability sampling, and also when the population is hidden or hard to locate. So this is called snowball sampling, chain sampling. All right, quota sampling, again this will not fall in this category because you already know the population and you are just assigning some quota for that population to select sample. Stratified and cluster, those are example already I discussed, that is about probability random sampling. Okay, basically population in stratified, you divide population into different strata, and from each strata you select sample. And in cluster, again here also you divide in different cluster. Unlike strata, you select only cluster as a this different between strata and cluster. Correct answer is 4. Okay, so let's see our solutions like. All right, so here is the explanation slide. You can see the example that I have given for snowball sampling. So what was happening there? You have some initial, subject, and then you refer to one person, and that person give you some reference, and then the person further again you get reference from the new participant, and this process continue. This is chain referral. This is snowball sampling. Snowball sampling relies on one subject referring another. It is only viable method for hidden demography. So whenever you have hidden demography, or you don't have any idea, any clue about any particular demography, and you are going for sample, then in those scenarios, snowball sampling will be the best option. As already discussed, stratified cluster are probability method requiring randomized selection from a known list. Quota lies on research chosen proportion, not peer-to-peer reference. So here again we have statement 1 and statement 2. Statement 1 is saying, what is in statement 1? Okay, so statement 1 is saying external validity refers to extent to which results of a study can be generalized to other situation, people, or time. Statement 2, internal validity is threatened when researcher cannot be sure that the independent variable alone caused the change in dependent variable due to history of maturation effect. Example. So here we have a statement 1 and statement 2, and we have to figure out which one is correct. So here we have statement 1 and statement 2, and we need to figure out which one is correct and which one is wrong. Statement 1 is about external validity, refers to extent to which the result of a study can be generalized to other situation, people, or time. And statement 2 is saying internal validity is threatened when researcher cannot be sure that the independent variable alone caused the change in dependent variable. You can take your time and what is external validity? Okay, we will do this with the help of example. Now suppose that you are studying, you are a student of MBA, you have completed final year exam, and you give your exam, you scored 90%. Okay, so you studied MBA, you give your exam, you scored 90%. This is fine. Now what happened? You come to know some advertisement that if you are MBA, then appear for this exam, and if you get selected, you will get job. Okay, so you appeared for that test and you got selected and you got the job. Or you may appear for UGC NET exam on the basis of your MBA. You didn't study anything extra because you know everything what you have studied in MBA. On the basis of that, you got selected in UGC NET exam. Now, what is happening here? You was studying MBA, but your application is going beyond that. Is being applied in some external environment like UGC NET exam, test you have given for any corporate. So this is example of external validity. This is what external validity say, that refers to extent to which the result of a study, that is result of MBA, can be generalized to other situation, people, or time, for UGC NET exam or any corporate level test. So this statement is absolutely correct. This is what external validity is. Now coming to internal validity. Internal validity is threatened when the researcher cannot be sure that the independent variable alone caused the change in dependent variable. Let me clear everything. So we will also explain this part with the help of example. Now let's stick with the same example. Okay, your MBA exam. You are studying MBA and you scored 90%. Some other student also studied, he scored 70%. There might be some other student, he might have scored say 60%. Now this student scored 90%. This student scored result 90% because he was studying 4 hours daily as a self-study. This student might be studying 2 hours and this student might be studying just half an hour daily. So here the independent variable, we are changing the independent variable. These are the independent variable which is driving the result 90%, 70%, 60%. Okay, these are dependent variable. Dependent on what? On study hours. Now, it's not that only these are the factors, but if I say that okay, these marks can also be hampered, not just because of study hour, but also because of student IQ. It can be also there is also some other factor like IQ, sleep pattern of a student, mood of a student during the exam. So if these are coming in picture, that means that our independent variable alone is not causing the result or changing the result of dependent variable. That is why we need to make this constant, which is called extraneous variable. Okay, so this is what they're saying, internal validity is threatened. So yes, our internal validity, that is example of dependent and independent variable, is threatened because of these external variable. If your outcome or result is not only because of independent variable, then your result is threatened. So this will be also true. So what is the correct answer finally? So finally statement 1 and 2 both are correct. So option A will be the correct answer. Both are correct. So you can see both are correct and explanation is also given here. So we can pause the video and you can just go through this, or I can just give you a quick revision here as well. Internal validity inside the lab, measure casual confidence and accuracy, threats, unplanned external events affecting the experiment, maturation. It can be anything, like one example we have already given. External validity outside the lab. So whatever results, whatever experiment you are doing, is it, or whatever study you are doing, is it applicable to real world in any other external situation? So if that is applicable, that means it is external validity. So that is validated externally. Key takeaways, internal validity answer. Did X truly caused by? Did X truly caused by? Here X is independent variable and Y is dependent variable. So can we say that by the cause on Y is only because of X, that is independent variable, or there is some external factors involved? Is there any extraneous variable? If that is the case, then our internal validity is not satisfied. And it talks about the accuracy. So we need to control the extraneous variable in this case. While external validity answer, does this result apply to everyone else? Does this result applies to everyone else? Generalization. This is about generalization. So external validity talk about a generalization. Internal validity talks about accuracy. The keywords you need to remember. Moving to next part. Plagiarism and ethics. According to UGC regulation on plagiarism, if a researcher is found to have level 2 similarities, that is 40% to 60% in their thesis, what is the prescribed penalty? This is a direct question. There is a table for this, and on the basis of that, we can answer this. Okay, so this is like you need to remember this table, you know, and on the basis of that, only this can be answered. I will not say there is any concept involved in this question. Okay, so what are the options? The options are like no penalty, just a warning, level 0. But already this is level 2. Submit a revised script within 6 months. Depart from submitting a revised script for 1 year. Registration for program is cancelled. So this happens, I think, when 60% and above. If your plagiarism level is 60% and above. Okay. So easily you can answer this from this chart. So when plagiarism is of level 0, then up to 10%. This is level 0, no penalty. Up to 10% of plagiarism, no penalty. Okay. 10 to 40% submit revised script within 6 months. If your plagiarism is between 10 to 40%, you can submit revised script within 6 months. If it is between 40 to 60%, debarred from submitting for 1 year. Okay, so this was the case, I think example. So answer C will be the correct answer. 40 to 60% debarred from submitting for 1 year. And if your level 3, if it is more than 60%, plagiarism in your report is more than 60%, if you have more than 60%, that means you have done nothing yourself. The registration for program will be cancelled. All right. So ideally, whenever we are doing any thesis, our emphasis should be that plagiarism should not be more than 10%. This is the most appropriate. Okay, so correct answer in this case is debarred from submitting a revised script for 1 year. Okay, so answer C will be the correct answer. Okay, next question is about research philosophy. The question is, which of the following research types is most closely associated with positivistic philosophy? Okay, so the question is about which of the following research type is most closely associated with positivistic philosophy. So first we need to understand what is positivistic philosophy. Already we have explained this in previous slide, but let me give you in simple terms what does this mean. So positivistic means basically nothing but science. It is combination of science plus facts plus number. Okay, it is combination of three things. So this method, positivistic philosophy, says that research is linked to quantitative plus scientific testing. This is what positivistic philosophy talk about. The research should be linked with experiment, absolute reality, quantitative and scientific methods should be applied. And if you see the options, then experiment research is one where this can be applied. Why grounded theory cannot be applied? Why you cannot apply this in positivistic philosophy in grounded theory? Because this is more interpretive. So that is because grounded theory builds theory from data, mainly interview and observation. You don't have much experiment here. So this is like a qualitative approach. So criteria of positivistic philosophy is not followed because this is qualitative, qualt. All right, grounded theory. Uh, we have ethnography. Ethnography is study of culture, people, behavior. So that's why no quantitative and no scientific method. Again, interview. Experiment research is correct answer. And phenomenography. Now this is like people experience and feeling. This is study of people experiences and feeling. So again, this is more like qualitative only. So correct answer for positivistic philosophy will be experimental research. Let's look at the explanation. So correct answer is experimental research, and you can see the difference of positivism and interpretivism, that is the distractors. Positivism, that is the correct path which relies heavily on objective reality, logic, precise measurement, and deduction. These are the keywords for positivism. Question can be asked from keywords also. They may not give you talk directly about positivism in question. They may talk about these characteristics and they will ask you that which one is the correct answer. Experimental research is gold standard of this approach. Why? Because here you have quantitative approach, experimental research, and also you are testing absolute reality basically. You are doing experiment. And here you require because you are doing experimental research, so you need to require manipulating independent variables, measuring quantitative results, which all are characteristic of positivism, which is the correct path. But you have just alternative to this, which says that which focuses on subjective human experience rather than hard objective and scientific measurements. Grounded theory, ethnography, phenomenology belongs here. These are qualitative approaches, not positivistic. Key takeaways: proving with precision, that is quantitative, and interpreting ideas, that is qualitative. And that's why that is called interpretivism. Okay, so let's go to the next question. Slide number question is that the question, you are a detective investigating. No, this is like a case study. A small case study is given here. Okay, a small case study is given here, and you need to figure out which type of research we are talking about. So the question is, you are a detective investigating the impact of remote work on employee mental health. Instead of relying on numerical data, you conduct in-depth interview, observe work pattern, and analyze personal experiences to understand emotions. Which type of research is this? Quantitative, experimental, qualitative, applied. Just need to guess the keywords here. Alright, so let's check the answer. First one is quantitative research. Now, what is the keyword for quantitative research? Numbers, statistics, data, marks, percentage. Are we talking about these things? Impact of remote work on employee mental health. Instead of relying on numerical data, you conduct in-depth interview, observe work patterns, analyze personal experiences to understand emotions. So we are not talking about numbers and quant. So that's why quantitative research will not come here. Experimental research. What is the keyword for experimental research? Cause effect, independent variable, dependent variable, manipulation. Are we talking about those things? No, we are not talking anything like that. So this example will be not. So experimental research is not the correct answer. Quality, qualitative. So everything that is being talked here, those are basically related to qualitative. So that's why we can say yes. But we also have fourth option, applied research. Will it come in here? But applied research is basically focused on solving real world problem. But question is about method used, not the purpose. Okay, so whenever we talk about applied research, we talk about real world problem. But here, what we are talking about is about a method which is used, not the purpose. So that's why qualitative research, because in qualitative research, all these things will come in picture, like interview, observe work pattern, analyze personal experiences to understand emotions. So the correct answer will be your qualitative research, option C. Here you can see the difference between the qualitative and quantitative. Qualitative, the why and how. Quantitative is how many. Both quantitative and experimental research inherently require numerical data, graphs, strict mathematical variable manipulation. Key takeaway: quantitative numbers, many testing, qualitative quality words, few understanding. Okay, so you can pause this and you can go, you can read this, you can take a snapshot. All right, so we have next question, and the question is given here. The marketing team wants to understand customer preferences for a new smartphone. They perform two actions. One, they analyze sales data and survey responses with numerical scores. Second, they conduct focus groups to explore customer opinions and experiences in depth. How is this research based classified? Okay, so let's understand this. So what they're saying, a marketing team is performing two actions. One is they analyze sales data, means we are talking about the numbers, and survey responses with numerical scores. So this is talking about the numbers. So this means this is the quantitative approach. This is quantitative. The first is talking about the quantitative research. They conduct focus group to explore customer opinion and experience in depth. Now, in second, they are talking about the qualitative. This is qualitative. So what we seeing here, first they are talking about quantitative, and in second they are talking about the qualitative. So this is a mixed research. This is example of both qualitative and quantitative. Why qualitative? Because you are talking about customer opinions, experiences in depth. That means you are also dealing with qualitative research. And here you are talking about survey responses with numerical scores, means you those will be dealt with quantitative research. So the answer will be both qualitative and quantitative. Okay, so here is the explanation. Mixed method, when you have data in stacks, that is action one, sales data and numerical survey. An interview focus group, that is exploring opinion in depth, strictly qualitative. So this is example of classic example of mixed method. All right, so again we have matching question. Match the research type with its goal. You have different types of research type and its goals. You need to match that. I've already Okay, so I've already told that whenever you get this kind of question, where you have on one side you have certain parameters or some certain topic, and on next you have explanation. So always go with explanation first. Easily you can pick the respective correct topic from description part. So let's go with list 2 first. Solves immediate problem in a specific setting. Example classroom. Now look at the keyword immediate problems. Whenever you are solving an immediate problem, this is related to action research. This is the keyword for action research. Immediate problem in a specific setting. So whenever we are doing a research for immediate result or immediate solution, that is the example of action research. Expands theoretical knowledge without immediate commercial use. So that means we are doing research that the just for sake of knowledge. So what is the example? Just 1 minute. Okay. So whenever expand theoretical knowledge without immediate commercial use. So we are just doing for sake of knowledge. That means we are talking about fundamental research. Whenever theoretical knowledge without immediate commercial use. Not whenever we are. Now third is uses scientific theory to solve general real world problem. Solve general real world problem. Scientific theory. So that means we are talking about the applied research. This is the case of applied research because we would applied research to solve the real world problem. Okay. So correct answer is your A. A is your correct answer. Already we have explained that. Now let's. So you can see the explanation for each is given here. Action, solve immediate problem. This is the keyword. A specific problem in specific setting utilizing the cyclic called PAOR. What is PAOR? PAOR. For action research, we have this is P is plan. This is plan. So you can see here we have a keyword PAOR cycle. So PAOR is a common terms in action research. This is nothing but P is plan, A is act, O is observe, and R is reflect. So on these four principles, our action research is built. Reflect means local fixing. So you are doing immediate solution. In that case, say classroom, you have some problem related to uh, the problem might be highly localized. Basically, we are doing action research for any local problem. Whenever you have some local level issues, for example, for a school, you might be having some uh, you want to improve teaching method in a certain school in certain areas. So for that you will perform action research. The problem, the use case here is the local, specific to that classroom setting. So that's why action research. Now again we have a question. A doctor wants to understand the root cause of a specific recurring disease in a population to treat it effectively. Which research type is best suited? A use case is given. A doctor wants to understand root cause, that is etiology of a specific recurring disease in a population to treat it effectively. Which research type is best suited for this? That you need to figure out. Okay, so in question only they have already given root cause, which is etiology, that they want to understand root cause. Okay, so can we go about fundamental research? No, it cannot give you root cause. It just give you initial knowledge about something. It will not give you the root cause. Exploratory, again, this will not give you root cause. This is used when this is used for initial understanding again. So here the question is about root cause of a specific recurring disease. Can we go with exploratory research? The answer is no, because it only helps in initial understanding. Initial understanding. Fundamental, we cannot go with, because this is just for sake of knowledge and theory. It will not give you root cause analysis. Descriptive and diagnostic. Now, if you see descriptive, what does it do? It's for what? Describe the situation. Okay, what is happening? How many people are there? It can give. But why? Why this happening? For that, we need to go with this diagnostic research. It, because it causes it finds causes of a problem. So whenever we are dealing with root cause, that means we are talking about why. The question is why is happening, and for that diagnostic research we have to go with diagnostic research. That will be the correct answer, because diagnostic research gives you finding the causes behind the problem. So here the correct answer will be diagnostic research. So diagnostic research answers. So you can see the this slide clearly explains about this question. Diagnostic research answer: what is the problem? Why it is happening? It is specifically engineered to identify the root cause of an issue and purpose. The key contrast by distract. tests fail. Key takeaways. Diagnostic is diagnosis. It's as simple as that. Identify the problem, find the cause, suggest solution. So these are the consideration, or these are the steps of your diagnostic research. So diagnostic research is very deep dive research where you not only identify problem, you also find the causes and you also suggest the solution. So this is the perfect, I will say match for the question, this question. So for this question, diagnostic research is the perfect. Next question. A psychologist studies the social development of a single group of children by assessing them at age 5, then again at age 10, and finally at age 15. What type of design is this? Research design is this. Okay, so there is one psychologist or researcher. He's studying behavior at age of 5, at age of 10, and also at the age of 15. So he is making. Okay, so what is happening here? Here you can see that same group of people. You can see that single group of children are being studied at different ages, that is different time. So there are two concepts. One is when your group or when your group of study is same and studying the same group over different interval of time, which is 5 year, 10 year, and 15 years. So your children is same, but we are studying at different stages of their age to analyze some certain behavior. These types of research is called longitudinal. This is called longitudinal. You also have here cross-sectional research. When you are studying different population, or so if the example could have been like you are studying different children at different interval of time. Now, if the question could have been you have different group of children at same interval of time, or at one time, different children at same time. So this could have been example of cross-sectional research. So these are the two things that we need to remember here. Longitude, this is not the correct answer. Correct answer here is the longitudinal research. Why? Because we are studying social development of a single group of children. That is same group over different time interval. So this is the example of longitudinal research. Cross-sectional, you are studying different group, you have different group, and you are studying at different group of children, but in studying at one time. Okay, so just opposite of this will be cross sectional. When group is more than one, when you have provided here. Think of null hypothesis as zero relationship. As zero relationship or no relationship. Any predicted relationship automatically becomes alternate hypothesis. Next question. This is on parametric test. Which of the following sets of conditions strictly mandates the use of parametric test? Which of the following sets of conditions strictly mandates the use of parametric test? So options are ordinal data, non-normal distribution, independent samples. B, ordinal data, normal distribution, paired sample. Or is it interval ratio data, normal distribution, homogeneity of variance? Or is it interval data, skewed distribution, heterogeneity of variance? Which of the following test of conditions strictly mandates the use of parametric test? So basically, what are the conditions for parametric test that we need to figure out? Okay, so here first we have to understood what is parametric test first of all. So parametric test example is t-test, ANOVA. This is your parametric test. Okay, so this is the example of parametric test. Now, what is the characteristics of parametric test? So whenever we are doing parametric test, then we have at three basic conditions. The first is that data should be numeric, no categorization. For that we used chi-square. So here the data should be numeric, and that is interval or ratio. Okay, that is one. Second, it should be normal distribution. Second is that data should be normal distribution. And third is homogeneity of variance, that is variance must be equal. Variance or equal variance. Variance must be equal. These are the three basic conditions that we need for use of parametric test. Example, t-test, ANOVA test. So now we need to, we know what is parametric test. On the basis of this, we can figure out which one will be the correct answer. Nominal data, no, this is not numeric. Ordinal data, no, this is also not numeric because ordinal is ranking, nominal is categorical data. Interval ratio, this is first condition is met, that is numeric data. Normal distribution, this is what we want, second condition, normal distribution. And homogeneity of variance, this all condition is met here. So C should be the correct answer. Okay, so option C, interval ratio data, normal distribution, homogeneity of variance. Option C is here correct. And you can see the three pillars of parametric test are highly sensitive and require strict assumptions. And what are those? Already we have discussed that. Let's repeat that again. That is quantitative scale, normal distribution, homogeneity of variance. These are the three basic criteria for performing which test? For performing parametric test. ठीक है. So we have quantitative, normal, and homogeneity. Parametric tests rely on population parameters. If data cannot assume bell curve and interval ratio scale, we cannot use them as parametric test. Okay, so now we are moving to the next question, and the question is on t-test and g-test application. So the next question is, we have two statements and we have to figure out which one is correct, which one is incorrect. A g-test is preferred when the sample size is large, that is, sample size is more than 30 and population variance is known. Statement 2. A student t-test is used when sample size is small and population variance is unknown. Okay, so here let us understand what is difference between g-test and t-test. So for g-test, first thing that we need is that standard deviation or variance of population should be known. In t-test, standard deviation and variance of population is not known, not given. That is one. Second, sample size for performing g-test should be large, that is greater than 30. In case of t-test, sample size is small, less than 30. So these are the two basic criteria for performing G and T. Whenever standard deviation of population is known, then we go for G test. When a standard deviation of population is not known, then we use sample standard deviation or variance, and for that we perform T test. And in this case, your sample size will be small. Both these tests are parametric, that is normal distribution is required. So let us see, both 1 and 2 are correct. So 1 is correct. A G test is preferred when sample size is large, that is greater than 30, and population variance is known. So this is absolutely true. The student t-test is used when sample size is small and population variance is unknown. This is also true. Population variance or standard deviation. So both 1 and 2 are true. So this will be the correct answer. You can see the explanation part in tabular format. We have presented that. So already I have explained these things. These are the different features for G-test and T-test. For G-test, sample size should be large, that is greater than 30. For variance, population variance is known, and key metric is standard deviation. For t-test, you need a small sample size, less than 30, population variance unknown, degree of freedom is n minus 1. If unknown variance or standard deviation of population, sample size is small, definitely signals the need for t-test. Now let us move to the next question and next concept also. In context of F test, now we have come to the F test. Identify the correct reasoning for its calculation and application. Formula for F test is S1 square, that is the variance of population 1 divided by variance of population 2. So which one is correct? The question is asking, out of these four statements, which one is correct in context of F test? A. F test is used to compare means of two independent groups if value can be negative. F test is used to compare variances S1 square by S2 square if value is never negative. F test is non-parametric test used for rank correlation. F test compares observed versus expected frequency. थोड़ा देर रुक जाओ, मैं आता हूँ, मैं ना आए तो आपको 10 मिनट रुक जाओ, मेरा हो जाएगा। 10 मिनट रुक जाओ, मैं आ रहा हूँ। 10 मिनट और देख लो टीवी, उसके बाद मैं ना आए तो 10 मिनट में आ रहा हूँ मैं। Okay, so now let's see the solution one by one. All right, so here A, which one is correct? The question is which reasoning is correct in context of F test. So F test is used to compare means of two independent groups if values can be negative. First of all, F test is not used to compare means of two independent groups. So this is absolutely wrong here. We use T test. This is example of T test, not F test. F test is used to compare variances. This is correct. And if value is never negative, this is also correct. Why? Because you can see the formula for F test, that is variance 1 square by variance 2 square. F test is never negative. The reason is that you are using square of variance in numerator as well as denominator, and whenever you will use a square of any number, the value can never be negative. It will be always positive, always positive. So this is the correct explanation for F test. If test is a non-parametric test, this is absolutely wrong. If test is a parametric test. If test compares observed versus expected frequency, this is wrong. This is example of chi-square test. Whenever we are talking about observed frequency and expected frequency, means we are talking about chi-square test. further explanation is provided in this slide. F stands for Fisher, fraction of variance. Because it uses squared numbers, it is always positive. F test calculates the ratio of two variance. Now we have matching the column question. You have parametric test given here, different types of parametric test, and list B is of non-parametric test. What we have to do? We have to match the parametric test in list A with their corresponding non-parametric counterparts in list B. So for every parametric test, we have counterpart, non-parametric test. Why we need this? Because parametric test condition is that data should be normal. When data is not normal, normally distributed, we go for non-parametric test. And we have counterpart for each. Okay, so we have independent t-test. What will be the counter for this? So when we use independent t-test, whenever we compare two independent group, whenever the two group is independent, then we go for independent t-test, and counterpart for this is Mann-Whitney u-test. This is the things that you need to remember. One-way ANOVA. One-way ANOVA compares more than two groups. So when we are comparing two groups, we use independent t-test, and for that we are doing Mann-Whitney u-test. When we were doing one-way ANOVA, that means you have more than two groups, three or more groups, then for that counterpart will be Kushkal-Wallis test. Pair t-test. For pair t-test, matching is correct. It should be Wilcoxon signed rank test. Pair t-test. This measure the linear. This is the non-parametric version of Wilcoxon signed rank test. So pair t-test, you are here things to remember. Here you have independent t-test, and for independent t-test we use Mann-Whitney. But if you have pair t-test, we should be going for Wilcoxon. And for Pearson correlation, we are doing a Spearman rank correlation, and this one is non-parametric version measured in linear relationship, and this measures linear relationship. So you can see the explanation. Independent t-test, again Mann-Whitney u-test, and this is for two groups. When you have one-way ANOVA, when you have more than two groups, you go for Kushkal-Wallis test. Pair t-test, it can be pre or post, and for that you will perform Wilcoxon Sign rank test. Pearson correlation, Spearman rank correlation. So next question is the chi-square test is non-parametric test. Which of the following condition represents a limitation or rule for its application? Next question is on chi-square test conditions, and the question is the chi-square test is a non-parametric test. Which of the following condition represents a limitation or rule for its application? It requires the population to be normally distributed. It can only be used if sample size is smaller than 30. The expected frequency in any cell should not be less than 5. It tests the significance of population mean. Which of the following condition represents limitation or rule for its application? So first thing, chi-square test, this is non-parametric test. This is non-parametric test. And whenever we are doing non-parametric test, we do not need normal population. Normal population is not required. So it requires population to be normally distributed. This is correct. We don't need normal population. So this is not the rule for chi-square test. It can only be used if sample size is smaller than 30. No, not necessary. We can use this for larger sample size also. So this is also correct. The expected frequency in any cell should not be less than 5. This is the correct requirement for chi-square. Expected frequency in any cell should not be less than 5. That should be at least 5 or more than 5. Then only we can perform chi-square test. It tests the significance of population means. No, it doesn't. It only tests the categorical variable where we have expected frequency, where we need to estimate expected frequency and given frequency. Here is the more detailed explanation. Chi-square is distribution free. That means it do not require normal distribution. It is highly sensitive to small expected frequency. This, as a result, no cell in contingency table should have expected frequency less than 5. Key takeaways: high 5 of chi-square. Keep your contingency table cell frequencies explicitly above 5 for effective result. So let's see one more question on assertion and reasoning. Assertion is saying parametric tests are generally considered more powerful than non-parametric tests. Parametric tests are generally considered more powerful than non-parametric tests. Parametric reasoning, parametric tests utilize more information like mean, standard deviation, and make specific assumptions about the population distribution. This is the reasoning. So assertion is parametric tests are generally considered more powerful than normal parametric tests because parametric tests utilize more information, mean, standard deviation, and make specific assumptions about the population distribution. So more information means more powerful. This is the standard rule. So in parametric test, what we do is that we are using more information. We are using information like mean, standard deviation, and we are also making specific assumptions about the population. So as a result, parametric test is more powerful than non-parametric test. This both are correct and reasoning is correctly explaining the assertion. So both A and R are true and R is the correct explanation of A. So here we can see you have more power in parametric test because here you use more information like mean and standard deviation. Parametric tests are precise and powerful. Non-parametric tests are flexible and free, and it is robust. So both have its own importance. So whenever we don't have like normal distribution data and we don't have much information about the population, in that case non-parametric test is performed because you cannot perform parametric test in case of categorical data. When your data is nominal, you cannot do that. So for that we have to rely only on non-parametric test. So both has its own significance, but definitely parametric test will be more powerful because here you are using uh, lots of information about population like mean, standard deviation, variance, and on the basis of that you are making lots of assumptions, and on the basis of that you are coming to your conclusion. All right, so this way we have come to the end of our important questions on research aptitude. The question that we have discussed, around more than 30 questions, all are very important from upcoming UGC NET exam, because these are the concepts, not the question, which are repeatedly asked on every exam. You will be not surprised if 3-4 questions you will get from these concepts only. So concepts cannot change, those are static. What change is the way they are asking the question. So questions of concept will remain same for all the upcoming exams, but question will change. Now it is putting effect on the so now we are also talking about extraneous variable. So from where does